cardinality of set. Let's say we are giving set A to values. Okay, we have the elements 1, 2, 3, and 5. We asked to find the cardinality of this set. Okay, quickly, cardinality simply refers to number of elements in a set, and this is how you represent it. The cardinality of this set, how many elements do we have? We have 4, so it will be 4. Okay, let's look at the challenging place. Okay, so we are giving these values. Okay, we are giving this value for 1. This is a question I have here. Y less than x is less than 70. Okay, and we are asked to find the cardinality of this set where x is a perfect square. Okay, so simple. You find how many elements are between 1 and 70. But let's do it, guys, together. We have 1 is the perfect square, we have 4 is the perfect square, we have 9 is the perfect square, 16 is the perfect square. Okay, we have 25 is the perfect square here, 36, we have 49, and we have lastly 64. So how many perfect square between 1 and 70? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 perfect squares. So the cardinality of this set where x is a perfect square will be 8. So guys, it's as simple as that. So this is how you can solve problems involving cardinality of a set, different states. So let's say you're given these values. We are giving set x to have its elements as 2, 3, 5, and 7. Okay, and we are given y to have its elements as 2, 5, and 11, and we're asked to find x minus y and y minus x. So what this means, okay, x minus y means the difference between x and y. Okay, what it means is you should find the elements in set x, not in set y. So as you can see, in set x we have 2. Okay, we're going to write them. In set x we have 2, and in set y we don't have 2. So that means we're not going to include 2. So we're going to clean these 2 and put the 1 in set x that is not in set y. So we have 2 here, we have 2, we have 3 here, we have 3. So we're going to start with 3. So we have 5, we have 5, we have 7, we don't have 7. So this is going to be the difference set between x and y. The difference between y and x will be elements in set y, not in set x. So we have 2 here, we have 2 here, we have 5 here, we have 5, we have 11 here, we now have 11 here. So the difference between y and x will be 11. So how do you deal with problems involving power sets? Now in this question we are asked, what is the power set of set A if set A equals these elements in the bracket? Now to solve power set, basically all you need is to apply the formula for power set, which is 2 to the power of n, where n is the number of elements in a given set. So in this set A, we have the number of elements in the bracket to be alpha, beta, and w. So we have 3 elements. So this shows us that the power set, we use P to present it, will be 2 to the power 3. Alright, so 2 to the power 3 is something. We are going to learn how to solve problems involving union and intersection of sets with Venn diagram. Okay, so let's begin with the example of problem I have here. Okay, we are given these elements in set A. So we are given set A to have these elements A, B, C, and D. Okay, we are given set B to have these elements B, F, G, and D. Okay, so we have to find A intersect B and A union B. Okay, so let's first of all represent this in a, okay, before we do the Venn diagram, let me show you. A intersect B means that you should find the common values in both set A and set B. As you can see, in set A we have B here, we have B, set A, we also have B in set B. Okay, we have D in set A, we also have D in set B. So A intersect B will be the common elements, which are B and D. So this will be A intersect B, whereas A union B will be all the elements in set A and set B in ascending order without repeating anyone. So we have it to be A, B, C, D, F, and G. And this will be our union of set between A and B. Okay, so let's represent the Venn diagram. To represent the Venn diagram is going to be something like this. This is Venn diagram. So remember, we have intersection of sets to be B and D. So we put it here, B, D. Then out of set A, in set A we have A, B is already here, we have C, D is already close. Okay, B is there, we have A, C. Okay, whereas in set B we have B2, we have B is already here, we have F, we have G. Okay, so this is how you can represent this problem in a Venn diagram. Let's wipe this and look at another example. Okay, this time around we have this problem. We are given set A to be, we have the elements to be 2, 3, 4, 5, and 7. Okay, so we have set B. We have the elements to be 4, 6, okay, 7, 8, and 9. We're asked to find A union B and A intersect B. So feel free to pause this video and see if you can attempt this. Okay, so let's do it together. Our A union B will be all the elements in both set A and set B, arranging them in ascending order. So when you do it, then you have something like this: 2, 3, 4, 5. We have 6 here, 6, 7, 8, and 9. Whereas our A intersect B will be the common elements in both A and B. The common elements in both A and B, we have 4. Okay, we have, which other value do we have? We have 7. Okay, so that will be the intersection. So to represent this in a Venn diagram, I'm going to have something like this. Okay, so we have the middle value, we have it to the intersection, we have it to be 4 and 7. So for set A, we have it to be, we have 2, 3, and 5. Whereas set B, we have 6, 7 is already here, 8, and 9. So this is how you can solve problems involving union intersection of sets and represent them in a Venn diagram. We're going to learn how to solve problems involving complement of sets and represent them a Venn diagram. So let's go into the details of the video. So I have these values. We are given A, well, the elements of A to be, okay, we have it to be 2, 4, 6, 8, 10. Okay, then we have elements of B, that's it B. We have it to be 1, 2, 3, 4, and 5. Then we have the universal set to be values from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so it has to find A complement intersect B complement. So quickly, our A complements will be the values in the universal set are not in set A, so we have them to be, we have 1, 3, okay, 5, 7, and 9. So that A complements. Our B complements will be values in universal set not in set B, so we have them to be 6, 7, 8, 9, and 10. Okay, so let's go ahead and get the A complement intersect B. Complements will be the common values in A complement and B complement. So we have the common values. We have 7 here. We also have 7 here. We have 9 here. We also have 9 here. So the complement will be 7 and 9. Okay, to get the, what if it has to find the union? So the union, as usual, between A complement union B complement will be all the elements, you arrange them in ascending order. So we have them to be 1, 3, 5, 6, 7, 8, 9, and 10. So this will be our union. Okay, so let's present this on a Venn diagram. To present a Venn diagram, we're going to have something like this. So this is A complement, this is B complement. So the middle values are going to be 7 and that's the intersection 9. Whereas the, okay, for A complements, we have the remaining values here to be 1, 3, 1, 3, and 5. 7 and 9 already here. In B complement, we have it to, we have 6 here, 8, and 10. So this is how you represent it in a Venn diagram. And with this, we have come to the end of the class. Hope you learned something interesting.